Welcome back. We are in Khan Academy, Algebra 1, and the unit is quadratic functions and equations. This skill is called quadratic word problems, factored form, so we're going to get some context and have to interpret some things to answer these questions. So here's the first question. A certain company's main source of income is a mobile app. The company's annual profit in millions of dollars as a function of the app's price in dollars is modeled by this equation. So profit, P of X, in millions of dollars is a function of the price, X, in dollars. Okay? So before we get to the question, let's think about what is this saying? This is saying that profit is a function of price. If you, as a company, charge nothing for your product or service, you're going to make no profit. In fact, you'll make less than no profit because just making the product available or the service available costs money. So then you need to charge money to make a profit. And you'll make more and more money the more and more you charge, until you charge so much that people stop paying you for the product or the service. So some people will keep paying you for it, but eventually you'll get to a point where you are charging so much that no one uses your product or service, no one pays you, again your profit is zero. So that function is going to be a parabola that opens down. So it goes like this. Here's our function, and at some point, that was horrible, let's try that again. At some point, your profit's going to be zero, here and here. This is when you're not charging enough, and this is when you're charging too much, and you're going to have a maximized profit based on hitting just the right price point. Okay, so let's look at this. Remember, it costs you money to charge for this, so our y-axis, or it's going to cost you money to produce the product or service, so the y-axis is actually going to be to the left of that first point. So down here somewhere is the amount of money it costs you to produce the product or service. You charge a little bit and you break even, you charge just the right amount and you make optimum profit, maximum profit, and if you charge too much again, you'll make zero profit. Alright, now the question, which app prices will result in zero annual dollars of profit? So they're asking us about the points where we cross the x-axis, because on the x-axis our profit is zero. Our y-axis is zero when we're on the x-axis. So what makes this function equal zero? Well, if any of the factors equal zero, then the function will equal zero. So we need to know where x minus 3 equals 0. That's at x equals 3. And we need to know where x minus 11 equals 0. That's at x equals 11. So our two solutions are x equals 3, then the profit is 0, or x equals 11 and our profit is 0. Those are our two x-intercepts. So our lowest price to make no profit is $3, and our highest price to make $0 is of profit is $11 per product or service. So, okay, those are our two solutions to this problem. Next, Ricardo throws a stone off a bridge into a river below. The stone's height in meters above the water, x seconds after Ricardo threw it, is modeled by this function. Okay? So, height in meters is our y-axis, and he's throwing it, so it goes up then it comes back down. So once again, we have a parabola like this. He started on a bridge, which means that my y-axis is going to, or the y-intercept is going to be above the x-axis, right? He throws it and it's up here above the ground, especially above the ground because he's standing on a bridge, right? Off a bridge into the water below. All right, so how many seconds after being thrown will the stone reach its maximum height? So they're asking about what point. If they want the maximum height, that happens right here at the vertex. Now, are they asking us about the height or the time it took to get there? How many seconds after being thrown? That's a question about the time. Time is our x input, and the height is our y input. All right, so they're asking us for the x coordinate of this vertex. All we care about is the x coordinate there. Now, since it's in factored form, the easy thing to find out is where are the y-intercepts, or the x-intercepts, theoretically. That would be at whatever makes this 0, so x equals 8, and whatever makes that 0, which is x equals -4. So those are the two x values here, -4, and here, 8. And we know that parabolas are symmetrical, so that means the vertex's x-coordinate is going to be halfway between -4 and 8. Okay, well there's 12 from -4 to 8. That's the difference between those two numbers. And we have to go half of that to get from one to the other. So we have to go 6 back from 8, that would be 2. Or if we go 6 forward from -4, that would be 2. And we don't have to figure out what the height is because they didn't ask us that. It's going to be 2 seconds after he throws the stone that it reaches its maximum height. All right. Simon has 160 meters of fencing to build a rectangular garden. The garden's area in square meters is a function of the garden's width. So that would look like this. Area equals -w times w minus 80. Okay, well, all right, so maybe this is -w, and this is w minus 80. That would be how we could represent the area. So the one dimension is -w and the other is w minus 80. All right, what's the maximum possible area? Well, again, this function is going to open down like that. And we have to figure out what are its two x-intercepts. Well, if w equals 0, if this part of our rectangle is 0, we don't have an area at all because we don't have a rectangle anymore. So 0, comma 0 is right there. And then 80 would make this factor 0. 80 minus 80 is 0. So 80, 0 is that point. They ask us, what is the maximum area? Well, the maximum area is going to be halfway between those because parabolas are symmetric. So halfway from 0 to 80 is 40. But 40 is what the width of this rectangle would need to be. Okay, if 40 is the width of the rectangle, is the W that makes one of the widths of the rectangle, then what would the maximum area be? Well, it would be 40 minus 80 is -40 times -40. When I put 40 in for W, I get that. Negative 40 times negative 40 is 1,600. So that's the number of square meters with the biggest possible rectangle. 1,600. Now I want to point one other thing out. If I put 40 in here, I get a rectangle that supposedly has negative 40 units for one width and negative 40 units for the other width. This is a problem geometrically, right? But what if I restated this original equation right here as negative W times 80, whoops, 80 minus W, like this. So I have the opposite. When I switch those around, when you take a difference and you switch around the minuend and the subtrahend, those are the fancy words for the thing that you're subtracting from. The first number is your minuend, the second one's your subtrahend. If you switch those around, you get the opposite number of whatever it was before, right? The difference becomes the opposite. And so, if I switch those around, but then I put another negative here, that will be equal to this, okay? Which is, negative times a negative is positive, so W times 80 minus W. This expression is the same as the one they gave us, so it would be, geometrically speaking, better to say that this side length is W, and this side length is 80 minus W. Now when we put 40 in for W, I get a side length that's positive 40, and another side length that's positive 40, which is good news because that can happen geometrically. What can't happen is a negative distance. We don't know what a negative distance is, right? Okay. Fair enough. Last one here. An object is launched from a platform. Its height in meters is x seconds after the launch is modeled by this. So the height, h of x, is a function of seconds, x, after its launch. Again, this is going to be a parabola opening down. Not all parabolas open down, but the ones that they gave us happen to. This is a projectile in motion. It's a physics thing, right? So if you throw a ball or if you launch a rocket or whatever you're doing, gravity is pulling it down. So you may have sent it up to begin with, but it's going to end up curving back down. So here's our parabola. We have an x-intercept where x equals -1, that'll make this 0, or where x equals 9. So -1, 0 is this point, and 9, 0 is that point. They ask us this question: how many seconds after launch will the object hit the ground? Well, it launched at time 0. It hit the ground where its height is 0 9 seconds later. So 9 is the number of seconds after launch that it hits the ground. And we are done.